used okay, I haven't used this in a while, so hopefully I set it up right and it's working correctly. Um, Once I've got all the drawings for the first set of cam lobes, for the exhaust and the intake, then in order to come up with the roughing G code, I needed to overlap the two and then just extract out of it the lobes on the circle, and that's what I need for a roughing G code for D2 and C. So I already completed that drawing, and this is the file that I take to D2 and C. That is the for the roughing pass to just remove the material, the excess material. Um, so from D2 and C, I'll go into Mach 3, go into D2 and C. Take a second to load. Hopefully it loads. Might have too much running on this computer. Here it comes. Okay. I'm going to select that drawing. Go to CAD, import DXF. Kind of hesitant here. I'm going to shut off some things. Close view windows. It's an old laptop and it doesn't move very quickly. Okay, I closed some stuff to free up some memory, and I need to select that that drawing I did with just the outside profile. Open it up in D2 and C. It's opening. Computer's moving slow. Okay, next I need to just click next, and that accepts the drawing. And then my point of origin is the center, so I want to click on center. That moves my drawing in. I need to figure an offset with the cutter size, so I'm going to click on offset, and I'm going to use a 1/2 inch cutter to cut the outside profile out. I'm also going to drill a little witness mark right here, and that is 0 degrees on this cam for aligning it for the timing marks. So I want to include that. So first I'm going to do the offset, which is I'm going to use a 1/2 inch tool, but I'm going to tell it the tool is 0.510, so I leave 5 thousandths of material so I can come back for a finished pass. So I'm going to type in 0.510. I'm going to select the outside, and I'm going to tell it to go ahead and offset that. It calculates it and then redraws it with the center of path for the cutter. And that's the shape that the center of the cutter will follow to cut that outer profile. Now I'm going to go back to shape. It's really moving slow. I didn't expect to be having this problem, but we'll see how it does. Let me just go ahead and go to path. I can always show you the drilling this at a later time. I can take the drawing and tell it to use any circle as a point of origin, and each time I hit enter, it'll go from the center of a circle to the center of a circle. So when I place that in the G code and I hit enter the first time, it'll move to this circle and pause and sit there and wait, and at that time I can just put a spot drill in and drill a little hole right here, and then when I hit enter again, it'll continue with the G code and finish this actual pass. But since things are moving kind of slow here, I'm just going to go ahead and generate the G code. Right here, now I want to click on contour, It brings my image up. I want to click on local shape, none, and just select the profile that I want to cut, which is just the outside of this part. I'll move that selection. It wants to know a full depth. I believe this is actually 0.4. It's a little under 0.4 tall, the material. So to make sure I go completely through, I'm just going to put 0.4 here. I'm going to take a I'll take a 25,000 step, because I haven't worked with much tool steel, and I want to make sure that I get it. I already set in constraints. I set this up for tool steel, and it'll give a feeds and speeds for the tool steel, which D2 and C is really conservative, so I can always adjust this later. I want to click on ramping because I want to ramp this cut, and it'll automatically calculate it. And then I can add this to my machine queue, and it's already wrote the code to actually generate this path, and 00 of course is in the center. So I'll generate the G code, and it will send it to Mach 3. Now once I have this code, I can click on tool path here and give me a little larger picture, and if I rotate this around to the side, you can see the actual path being cut. I wanted to put 25,000, so I put a 1/4 inch, but you can see this isn't the code I'm actually using, but I wanted to just show you a representation. So this for the G code's pretty easy. The harder part is going to be the actual coming in and cutting these profiles from the side, because one is under the other, and the cutter will have to pass under these lobes to cut the next one. So this underneath this top lobe will be a full circle, full portion of the arc under here. So that'll all be hand coded. Now I'll do a video on how I hand code that to remove the material underneath this section, and then to actually do the finish pass of each lobe and the area in between each lobe. It shows 8 lobes here, but there's only 4 lobes on each level, one above the other. So if I actually went back to the run program right now, tip this sideways, and hit cycle start, it's asking for the tool change. I hit cycle start again, and you can see it actually run the code and cut out the part. This part of roughing it out has nothing to do with the actual rotary axis, but in order to do this and keep everything lined up and centered, the material will be mounted on the rotary axis so that the next part of the G code is all centered up with what I've already done without dismounting and remounting it. So it'll all be set up to do in a fixture, so that if I have to remove it from the machine, it's easy to zero and come back and do it again, because I'm going to test this several times on probably first aluminum to check the code, and then move on to the final part. And by doing it in a fixture and centering every part every time, when I get to the final part, if my finish isn't exactly what I want it to be on the final passes with the handwritten code, instead of being an end mill, I can actually use the same code and mount in a grinder and grind this profile. So we'll see how it goes. There's a lot of steps to this, but this is the beginning. That's it for this video. Thanks for viewing.